So solutions to common errors. In order to do that, we're going to have to run an analysis. So let me go ahead and remesh first and then run my analysis. Now there are errors and warnings that can pop up both in the meshing process and in the analysis. In the meshing process, it usually has something to do with your geometry. There's a variety of different common errors that can happen. Maybe you have duplicate columns copied on above or below designations. That's a good one. Or maybe a column or wall happens outside of the slab. Potentially loads could be outside of the slab. So all of these will affect the mesh. You can see that I do have a warning that's popping up with the mesh, so we'll talk a little bit more about this after we get our analysis complete. So let's go ahead and push through. The other nice thing about Concept is that it has both warnings and errors, and then with the errors it also has a soft error. A soft error will let you push through the analysis, and so continue on through the analysis, and then a hard error will just completely halt the analysis. All right, so I'm going to have a couple warnings here that's going to pop up regarding my tendons. So whenever an analysis warning pops up, and we saw this in the mesh as well, usually coordinates are given. If it's based on a strip design or a span detailing, it will usually give you the strip designation as well. All right, so we'll just push through those warnings. So I don't have to get bogged down looking at every single warning that pops up. I can get through the analysis, and then when I want to go back and review the warnings, I can go over in the Explorer view to the Calc Log. The Calc Log will have a complete list of all the warnings, so I'm not having to, write down on all little pieces of paper what's going on and what's failing. So I'll be able to go through here and kind of kick through these or grab the whole bunch of them at one time and kind of detect what's going on. All right, so let's talk about the meshing problem. So first of all, it gave me some coordinates, and the coordinates were roughly like 27 by 47, I believe. So if you hadn't noticed it before, down here in the left-hand portion of the screen is a coordinate system for RAM Concept, and as you scroll the cursor around, you'll see the coordinates will update. So that's one way to kind of clue into where this problem is on the floor. So it was like 27, 40 something. So as I just move my cursor, or 22, 40 something, as I move my cursor in, you can see that it's right in this area. So my first option is just with my naked eye to kind of zoom in, see if anything is an issue. The particular warning that we got about the line set is a warning that comes up when the finite element mesh is created and you have two nodes that are very close to one another. The tolerance is about 2 inches in Concept. So if they're within 2 inches of one another, it wants to merge them into one point. So while I can't see that here with my naked eye, the best place to check that out is on the element layer. Now sometimes a warning is something that you can just ignore. You will have to use your engineering judgment on that one to decide if it's something critical or something that you can ignore. And as you look in here, you'll see that the column still appears to be the right shape. There's no problem really with the finite elements through this location. So I'm going to say that this is just maybe a fussy warning and I'm okay with it. What you will see though in certain situations, like 2 slabs coming together perhaps, is if it merges that node together, you might see an anomaly of difference in slab depths or difference in the slab edge that you didn't define. And so that's what you'll be able to detect on the element plan. Another great way to kind of jump into these errors and warnings is through the various perspectives that RAM Elements has to offer. Almost every layer has a default perspective set up, and all of these plans and perspectives can be customized by by the user, or additional plans and perspectives can be created. So the first one that's a great one to go to is the element layer. So I can kind of finalize my decision about this meshing warning that I was getting by reviewing the perspective for this particular area. So I can just simply come into my 3D view and kind of zoom in so everything's still looking good to me. And then I always like to flip over to the soffit. And again, I don't see anything crazy happening. I've got that drop and the beam coming into the column, so everything is still looking really good to me. So I'm going to maintain my thought process that I'll ignore that warning for now. All right, some of the other warnings that came up had to do with tendons. So let's jump on over to the tendon layer. And I guess one of the ones that you always cross your fingers and hope you never get is when the tendon is out of the slab. That's probably one of the hardest ones when you're looking on plan to determine, you know, where the heck the tendon is outside of the slab. You have essentially just a bunch of coordinates. You have a bunch of elevations, and then you have the picture of the slab, so you've got to think about what's going on. It's very difficult to see here. Each tendon layer has a perspective, both in the generated and in the manual layers. And so with this perspective, it's much easier to see those issues. Now, maybe not so much from the top, although it could be sticking out of the surface. I have by default the soffit on here, so I'll just rotate this around, and I'm going to zoom in. Let's get it into a good spot. All right, so there's the problem right there. The tendon was put in place right to the edge, and then it's given a certain elevation, but now the beam is in this location as well. So just that drape is causing it to jump between the slab and the beam. All right, so that's a problem, and that would be something definitely that we would have to go fix. And we will fix that through altering either the parameters or putting in some manual tendons in this location. All right, so I'm going to put this warning, or this warning on hold for right now. And let's take a look at one more perspective that's going to help you out as far as determining or reviewing your cross sections. So in addition to the 2D plans for the design strips that we've been looking at, initially when you lay them out, you get this nice hatching just to show you the coverage of the slab. Under visible objects, once the analysis is complete, you can turn on your cross sections. So that's the number one helper, is by turning on the cross sections. You can kind of see what's going on and take a look at where it generated those, because remember, they're automatically placed. You can make user adjustments to the cross sections, and you can also, there is a tool, maybe a little known tool, a cross section, adding your own cross section, design cross section through the slab. So you can manually define your own cross section if you like. Let's go to the perspective, because that's what I'm about, or what I'm after today. Because in this perspective, you kind of see the elevation of the cross sections as well as the the geometry of the cross section. So rather than it just being a line, you actually see the shape and the design depth of the cross section. Now, some cross sections are going to be solid here. That's the critical design area. Some will have a solid portion, and then what more looks like a hollowed out portion. Only the solid portion is used for the critical section dimensions in your design strip calculations. Now, I don't think an efficiency talk would be complete without jumping into the conversation of trimming. So just like with our design strips, I think I could talk all day on those. Trimming is another topic that we could talk forever on. When you look at the trimming options, let me just jump back one plan real quick so that I can bring back the properties. We'll look at trimming real quick. So you have a cross-section trimming. None is an option, and all of my strips today are defined with no trimming at all. And then you have a variety of different trimming options. Then in addition to that, you have the cross-section slope limit. And I found over the years, talking to many different concept users, that while there might be an okay understanding of trimming, how this cross-section slope limit used is maybe not as clear as of a topic as the trimming is. So first, your main trimming will be happening on your strips. That's the first thing that happens. And then after the main trimming happens, the cross-section slope limit comes into effect. All right, let's jump back to the perspective. Now, with that said, that I have no trimming set on all of these sections, you'll see that Concept is going to pick a critical section even when you have steps or drops or depressions in the slab, beams as well. All of that's causing it to pick critical areas. So I would say use your trimming with caution. A well-trimmed slab is an efficient analysis, but using trimming all of the time for every scenario, I think is a little bit of an overkill. So Concept does a really good job at detecting the critical section for most general slab layouts. Before you decide to use trimming, I would suggest that you come in and take a look at this perspective and just kind of review how Concept decided to trim all of the different cross-sections. Now, sometimes it may have chosen to do something a little crazy, or you have a more complex geometry. That's when you can go in and define additional trimming. So, of course, your design results are only as good as the cross-section that's been created, and it's only as good as the dimensions that the cross-section encompasses. Before we go off of this plan, I just want to take a look at how I redefine the design strip for our T-beam here. We've got the top location, and then we have the bottom one that I modified. So as you can see, we have uniform cross-sections across the board, and that's great for our T-section. And then we skip, it's a little bit more tightly spaced, but we skip down to some more uniform sections. If you look across the top, as it's going across, it looks like it's going okay, and then it hits that girder or member framing in, and now you've got this big, huge mass of concrete that it's trying to detect in the cross-section. So I guarantee when we look at that design of the beam that there's going to be, something that you just inherently are not going to agree with, and you're going to spend time problem solving it. So just by cleaning it up in this way, you're going to get a much better design. Now that cross-section slope limit, how that's going to affect, it's not going to affect the cross-sections as you see here. And it's really hard for me to show on screen because it's not illustrated well through these cross-sections. But when you have an instance where the members are, or your cross-section is changing elevation, like I had here in this section, it can cause an error. Because of this cross-slope limit, it can cause an error where virtually there's no concrete within the cross-section. And we're kind of seeing this location, or this phenomenon here, where it's not that solid color, so what's going on? There's no information. If there's no concrete in that situation, of course you're going to get an error, and you're not going to get any detailing in that location. What happens with the cross-section slope limit is it's going to compare the two cross-sections one from the other, and it doesn't want the forces to flow in a very angular way. Forces naturally flow along a more gentle slope. So it's going to kind of change or trim back the soffit and surface of the slab to allow a more gentle slope between these angular areas. It's also going to give you more concrete section than in the cross sections that you view.